Today we'll be finding how many grams of argon are present in this flask. And we're going to do it in 4 easy steps. First, we're going to find the partial pressure for nitrogen. And then we'll find the moles of nitrogen. Right after that, we're going to find the volume of the flask. So that in step 4, we can figure out how many moles of argon there are and then convert those into grams. So according to the question that we were given, argon exerts a pressure of 962 torr, and then when you add nitrogen in it, it increases to 17,000 torr. But we know the total pressure and we know the pressure of argon, but we don't know the pressure of nitrogen. So to find that, we're going to subtract 17,000 torr of total pressure, yes, it does say TP, from 962 torr of argon, which equals 738 torr of nitrogen gas. So now that we found the torrs of nitrogen, the pressure that's in the flask, we're going to convert torrs into atmospheres. So we're going to take 738 torr of nitrogen gas and divide it by 1, multiplied by 1 atmosphere and divided by 760 torr. And we will get 0.971 atmospheres of N2 gas. So we've been given 0.422 grams of nitrogen gas, and to convert into moles, we divide by its molar mass, which is 1 mole over 28 grams of nitrogen gas. And then we get 0.015 moles of nitrogen gas. Ta-da! Okay, so now we're going to find the volume of the flask using all the information we gathered for nitrogen gas. So it will work in order to help us find argon, since the volume of the flask of the container itself doesn't change. So we're going to use the pressure of nitrogen that we found, so 0.971 atmospheres. Since we don't know the volume, question mark there. The moles of nitrogen gas that we found was 0.015 moles. And then we're going to use our constant, 821. And then the temperature, which we've been given here, which is 34 degrees Celsius. We're going to use that. And convert it to kelvins by adding 273.15 to it. So 34 degrees Celsius plus 273.15 kelvins is equal to 307.15 kelvins. So we're going to take all this information and put it in the PV equals nRT for volume, which is V volume is equal to nRT over P. So we're going to put 0.015 moles times the R constant, 0.821, times the temperature, and then we're going to divide all of it by the pressure, which is 0.9 71 atmospheres. And then our volume will equal 0.389 liters, or 0.39 liters. So now, since we have all our information that we need to solve this, we're going to find the moles of argon. So we know what the pressure for argon is. Which is 962 torr divided by 760, which equals to 1.27 atmospheres. The volume, which we found in the previous step, which is 0.39 liters. We don't know what the moles of argon are, which we're going to look for. The R constant, which is 821 moles times temperature over, over the liters times atmospheres, and then the temperature, which we found 37.15 kelvins, since the temperature is constant throughout. So we take all the information we have and solve for moles. N of argon is equal to 1.27 atmospheres times volume, 0.39 liters, and divide it by the R constant, which is moles times temperature over atmospheres liters, and our temperature, which is 307 Kelvin. It's kind of hard to fit in here. Divided by 307.15 kelvins. So, after we calculate all that, the moles of argon is equal to 0.0196 moles of argon. So now that we've found the moles of argon, we're going to convert it into grams. So we're going to take 0.0196 moles of argon and multiply it by its molar mass, which is 39.90 grams per mole. Grams goes on top since we're looking for grams of argon, and that will equal to 0.784 grams of argon. And there we go. So our final answer was 0.784 grams of argon. Dun, da, da, da. And we're done. All it took was 4 easy steps. Bye!